The first thing that I'm gonna do is just read the code because I had an agent do the improvements since last time, and I didn't actively do anything since then. And I think I had a good idea of one potential direction that I can take this. I think so far, what it has, like, not sure if I'm gonna be. Yeah, so when I press a key on the keyboard, it does a sound. And then I can change the sound on the parameters here as well. Pretty interesting. And the idea that I have is to see if I can do something like a monkey type, where I have the words, and then as I type, I create the wave, create the sounds. And I think that's, I forgot the thing there. I need to have, the thing that I was just thinking about now is how I'm going to set up the waveform. And I think I need a way to, I think the best option is probably to have the sounds, to do the sound right away, but then to build the wave as I do the sound. So like keep track of the history, then build the final waveform, and then have some way to erase the history. That's probably the best thing to do now. I'm just gonna look into the code first to see what is going on since last time. And I kind of have roughly looked into this here. It's not that complicated, I think. So it's still strings here. Maybe just like compromise and just leave it like this. Actually, I'm not really sure because I do remember, I do think that it changed on the Rust side to accept keyboard, the keyboard event parameters. Maybe place the event somewhere. And this is just for showing like on the visualization there on the UI. So it encodes based on this. So I think that the shortcut is going to be key, and then the actual key is this the string. And then it probably has the events somewhere. Yeah, so this is just the UI layer. Then it has this, which is the snapshots from the, uses this React thing here. I think is a more effective type of store for reactivity, I think. And this subscribes to the changes. This is probably the list. So this is a listener, map a callback function, so that when the state changes, it calls the functions here, I think. It probably has an emit function there, from what I've seen. Then it emit changes, and I think the snapshot's just the state of the class. So basically, the waveform, the sample rate, the keys pressed. This controls here. Controls, I think, is the parameters there. So like these things here, the sliders here, and I think the waveform as well. Since from what I asked to GPT, I think that is not actually change, is always a sign, I think, or something like this. It's not actually changing based on this the waveform here. I don't really care that much, and I'm not really sure if I'm gonna go like with this because there's probably more parameters as well. So what I'm thinking about is like one of them I think is the most, like, the easiest one to know is the pitch, but then there are probably more that I don't remember right now. But there's definitely more types of controls here. Then he created this adapter as well and initialized the key with the adapter, probably initialized on the context. So it has as a state, then initialize the instance here. This returns the class, I think, with the adapter. So it creates the class on the static methods. The adapter is the WASM bridge, I think. So initialize the WASM with the function from the. This is what you get on when you compile to WASM on the Rust side. And this WASM engine is basically the engine on the WASM side. This is the engine, right here, or it assigns here. That is kind of confusing. So it creates the WASM engine here and assigns here. But then how does it? Also, it doesn't accept anything. So it creates here. This is this one here. Yeah, that makes sense. It creates the Rust engine here and then passes us dependency injection here. And then this becomes the engine here on the WASM adapter here. It's basically calling these methods from the WASM from the Rust side. The keyboard event that controls. And then I assume obviously it's going to change the state on the Rust side. So the Rust side it keeps track of the states of the events and their controls. I think what I have to do is just add a function to reset the event so I can start from scratch, let's say. So it is capturing everything, but it doesn't do anything yet with the events. So I think this one probably removes. Not really sure what it does. I'm gonna ask GPT. So let me think about this. They should probably like trace or follow the flow of execution of what happens when I press the key. Functions they get. Because what I want to do first, I think, is right now when I press the key, it does a sound, but it doesn't show. Yeah, I want the key to change the wave, and I think the key probably like they are all playing the same sound. I think so. They just play the wave. They don't change the wave. I think the first thing that I want to do is actually change the wave based on the key I press. This one it renders. So I assume that it's probably just calling this function. I want to follow the first. I have to search to figure out where it is, then follow the flow of execution. This is the controls open, and this is it just changes the visualization based on the samples. Uh, Initially, I was thinking that this was broken, but I think that it's just it is probably the correct way to do it, and probably don't have to change because everything else is gonna happen as a byproduct of this. I think because this is like the final sample you get from the transformation. The sample is very simple, just the variation of the values of amplitude. I think across time. I think that the x-axis here is time, and then the other one is amplitude, but not really sure. On the keyboards, it looks like it is just so the thing is gonna come from here. The engine subscribes, get snapshots. So the snapshots is the thing that changes. It sets the control on the adapter. This is kind of weird. I'm not really sure if I like this. Like this class seems unnecessary, but it's not that big of a deal, I think. Okay, let me think. I assume that probably is capturing the event on the window. Or is capturing here. Let me just cause this on the engine. So assume that it's playing here, obviously. So the render is probably gonna, so it adds the keyboards before there by calling the other function, which changes the state of the class, I think. And then gonna place the sample here. This is gonna render on the engine, which calls the main function there. So this function here, and this builds the samples. I'm not sure about this, like why he's using max here, max 0. It's kind of weird to me. So this is true times frequency times time to remember. I remember from the Fourier series that you use e to the power of this, I think, and then is the integral of that. But I'm not really sure if it's doing. It's not really the same thing, I think. But maybe it is. No, actually no, because I don't have the Euler here. I'm just doing a sign based on the frequency, based on time, based on the sample rate. But I assume that this is just a boiler, like placeholder. And it doesn't. Yeah, this is the function that I have to change probably. So I have to figure out. The question is how to. What interesting ways. So like the first thing that. Actually, there's two different things, different paths. Like, I think the first one is just to figure out like how to build. So each key should change the sound in a way, in a different way, and then it should immediately show the change on the front end, which I think is gonna do by default if I change this function so that it takes into consideration the history. Is gonna show there immediately. Because right now it's always producing the same sound, which doesn't take that into consideration. So that's the reason why I think it doesn't change the visualization here, only changes when I change the parameters. Because the parameters are the only thing that are changing the actual wave. So when I press the thing, it doesn't change the wave. But if I think if I incorporate the history of the events, it's gonna change the wave based on however I want the history to change the wave. So that should be enough to make it like instantaneously show the audio, but then I need a way to capture that state to be, like build up another wave with the whole history. So like kind of recording the audio. So I have like a whole track after. Then after that, I think that's probably the easiest thing to do is to implement some text like monkey type, but it might be hard to do that. I'm not really sure how it works because you have to implement the cursor, and the cursor is probably kind of annoying. But I think I can use an agent to easily do that, probably. Obviously, I don't really care about that much either. Would be more interesting to see like you generate some text, then you type the text just like monkey type, but then you place the audio as you type, and then it builds up the wave. Then the next thing, which is the one that I'm more interested about, would be to train AI models on top of that to change the sound somehow based off this initial baseline. That's what I'm most interested on. And so here it just pushes to this, so this like is gonna capture the state, the press keys, and then the event history captures the event. So the question, I think the first question is like how to change the render so that, and this is where I was thinking about creating a finite automata. I think that's probably the most interesting thing to do here. I'm gonna ask like GPT what it thinks the best name is for the file. Then I create another file with a struct in the implementation. Not sure if yeah, I think it's probably struct and implementation is probably the best because the struct keeps track of the rules, I think. And then the implementation has the algorithm that checks the rules to, so like it receives the strings, the vector of strings, loops over the vector of strings, checks the rules based on the state, and creates a graph that produces audio data based on it. I think that's probably the best thing to do. The first thing I'm gonna ask first, like what does it think? Because to me, that's the weird thing here is that the controls only have volume and frequency. Where's the duration here? So it is using all three values, but it doesn't seem that the frequency has. Maybe what I can do is just like quickly. Yeah, but I think I have to compile if I want to test. And I knew I was gonna forget the command. That's why I wrote here to compile. I'm not sure. Yeah, I need to go inside the crates. Not sure if I need to restart the web part as well, based on this. Okay, so the volume, I think it makes sense to cap between 0 and 1 because it's a percentage. But before it was already working, right? So I'm not really sure what that's about. So I'm gonna ask GPT why the agent did this. So there's the first thing that I'm gonna ask. Then I'm gonna ask, what does GPT think it will be interesting to do with the records of the keys there. Oh, the other thing that I was thinking about as well is like it will be interesting to create experiments where I feed a bunch of letters, a bunch of inputs automatically, instead of having to click to see what sound they produce as well. And so it's a deliberate placeholder. That was cleanly okay. So I think that's pretty much it. So I should probably just start asking about. I'm gonna ask about the. I think I can actually the resets as well. I need to create something that this adapter thing is kind of annoying too. I'm thinking about changing this because it seems kind of useless because the only thing that it does, like I just have to relay the function. Doesn't make sense. Why not just use the engine directly? I think I'm gonna use an agent for this. This is the other thing that I'm gonna ask. Maybe I can merge myself. It's just kind of annoying. What if I just did this here? And then I just make it the ninja. This. Yeah, I think that makes a lot more sense actually. Then I do this here. Maybe because of the constructor though. I think it's because of the constructor. These engines are right. Just do it here. Yeah, it is kind of annoying. Maybe that's why they did the adapter there, because I can make it like this, but then it is kind of annoying because I have to check every time. I don't know what is going on here. Like, why is this an error? I also don't understand. So I guess this is just to initialize the module, make the other function work. Ah, it's because of the static. That's why. Hmm. Yeah, but what if I just remove this? I can either do this. And this is the most annoying part. Like, how do I make it so that? Because if I remove null, then it's gonna force me to initialize in the constructor. But then if I do it like this, then it's gonna force me to check whether or not it's null everywhere, which is kind of annoying. Maybe I should revert back. Well, I don't know which thing is more annoying. I think it's probably more annoying to have to, because essentially the other class is just like relaying the same stuff, which doesn't make sense. What if I initialize the engine outside? But then, like, it's basically the same thing. Maybe what I should do is just initialize the module outside, and then have the engine receive the WASM module. That makes more sense. So instead of doing like this here, I do it outside, and then I build the engine based on this. Yeah, so I don't feel like doing this, so I'm just gonna figure out like how to ask GPT for a prompt that allows me to have an agent with client do it. I think basically what I have to do is figure out like how to move this into the context somehow, Then I initialize the WASM outside, and I pass the module. I initialize the constructor. Because the weird thing is that but I assume that you need to call this function before you call the engine constructor here, and that's why. So I need to guarantee that the class is initialized after I call this, after this has run. But I can do this on the constructor. That makes more sense. Maybe I should just do it myself, actually. Not sure if it's worth to waste the credits. I think I'm almost done, but it's kind of annoying to figure out like the correct way to do this on here. Or if I just move the function here. Forgot how to do this on this course. Hmm. Yeah, but I think. Yeah, I have to. I have like had a similar pattern happen sometimes, and I think I need to declare. I don't really like doing this that much, but I think you need to declare here so that I can set the state after. I think that the cons is probably better. I don't remember if I was, yeah. Actually, to find. Yeah, in each puts here. So I can use a use graph or keep it as a state. Not sure which one is best. It's because of this. Actually, maybe that's a mistake, sure. Then you should copy the other functions first. Or that has the same thing. It's already changed here. This. Yeah, I think now I can delete because I probably have everything on the other one. It's gonna be the same thing. Board events. I think I already did this one. Then this thing, blah blah blah. Yeah. So pretty sure I can delete now. Okay, so something going on because I can't change the value. Maybe to do with the context probably. So let me think. I think I don't need to ask GPT for a prompt. I can just ask an agent now to fix without well trying to make it not add entropy again. But I'm pretty sure it's probably something to do with the context. I think that is not like if I put the graph here, then it's gonna create an infinite loop. Yo man, I'm not sure. Not sure if I can trust this message, but yeah. If it is real, then thank you. Kinda looks like a bot message, to be honest. Yeah. I can't. Whatever. Yeah, so I think what is happening, I'm pretty sure I had this problem before, is that it is probably initializing and then like it renders once and then it never re-renders with the updated value. So I do like when he runs the use effect, like when he runs the component, he sends this as a no because the thing is not the use effect doesn't run yet. But then it creates because it creates a sync here. I do think that it is creating, but it's not updating. That's the problem. Yeah. So let me think what's the best way to fix this. Hmm. I don't remember if I can. And maybe if I use another variable. Yeah. Yeah, so I can use a use state here again. I'm not really sure if that's the best way to solve this. No, but this is like, wouldn't it create an infinite thing here? If I put here, maybe. That blocks the infinite loop from happening. Not sure. Yeah, yeah. I'm not sure if that's the best way to solve that. Okay, so it seems that it is working now. We're just gonna delete this. Let's see what GPT says. I'm just gonna add the thing that I'm not really sure about. It's probably really easy, just reset the state. Like, how do I do it? Uh, so it's probably just, and then I make the history equal to the default value there. But in Rust, I'm not really sure if there's, like, because of ownership and mutation, I'm not really sure how it works. But I think I can just do that. But I think I'm just gonna reset the event history and not the controls. Probably the best separation is to have like the controls is just a reflection of the UI. So it doesn't make like since they don't have any history, the history doesn't impact the wave. But maybe it makes sense to capture different parameters based on the time. That might make but I think that either way I should just keep the function separate. Then I decide based on the flow on the front end, I think. Actually, I need the mute, I think. Not sure how it works. I can look into the other ones. There's mutes before. Then I just need to copy the same way that they do the other ones. I'm gonna add reset controls as well and just put it on the controls as the default. And the other thing I can do is just obviously pass. I think resetting is easier than passing the same controls as the default. Maybe actually I don't need the. I think that for the controls, it's probably better to just leave it like this and never reset, and then just change. But then the question is like, how do I capture? Because I'm thinking about like running experiments. So after I create the finite automata, so the first thing is to create a finite automata that uses the keyboard shortcut history here to change the final waveform based on the symbols. So the finite automata receives the symbols, processes them, builds different waveforms based on the symbol and the symbol sequence. That changes the final result here. That's the first thing. But then it might be interesting as well to change the controls based on experiments for each, like based on the time. Yeah, because I might want to build waveforms where the main frequency changes, obviously, but The question is like where to put this. Because I think I need to change the entire class if I want to make it. If I want to make it so that the controls can change based on the sample, then not the duration. Maybe the duration. Yeah, but no, duration doesn't make sense because it has to like be. Doesn't make sense for the duration to change because the duration is the whole thing. But the frequency and the volume, it might make sense. Mainly the frequency, obviously. I think the frequency makes a lot of sense. And like I said before, there's also the possibility of having a lot more control. So I could have a bunch of different frequencies as well. This is the thing that I'm not really sure. I'm not sure if I want to remove the controls and then just make a base. I think removing the controls might be better actually. Or maybe I just leave the controls as a fixed thing and then I just like removing the frequency maybe. Like the volume and the duration is probably fine to leave it as controls. The frequency, maybe not, because what I'm thinking about is more like building the waveform based on the sequence of events. And having like a fixed frequency doesn't make a lot of sense, I think. Let me see what GPT says.
Here. First, though, the current render is worth understanding precisely. What render is doing the current function is deliberately used a tiny signal generator. The comment says the main purpose was proving that the Rust vec-f32 could travel through WASM and then be used by the browser. Take this, Rust buffer underself, vec-f32 let sample underscore rate sample underscore RAT 32 let total underscore sample self controls. Duration sample underscore rate round size limit samples vec with underscore capacity total underscore samples let rec self controls frequency. Max 0.0 let volume self controls volume clamp 0.0 1.04 in 0 total underscore samples let IS32 sample underscore rate let sample 2.0 STDF32 const 5 frequency t. Sin volume samples push sample samples mathematically. It is sampling this function where a volume f frequency t times seconds at a sample rate of 48,000 hertz. You aren't generating a continuous sine wave. You're asking what is the sine wave's value at t0 48,000 t1 48,000 t2 48,000 t3 48,000. So this Rust let IS32 sample underscore rate converts sample index into seconds. For I24 underscore 000 t 24,000 48,000 0.5 seconds then Rust 2 pi ft. Sin asks for the sine wave amplitude at that instant. Total underscore samples this Rust let total underscore sample self controls duration sample underscore rate. Round size means duration 0.5 seconds sample underscore rate 48,000 sample seconds 0.5 times 48,000 24,000 samples so half second sound gives you a Rust vec-f32 with 24,000 values. Vec with underscore capacity this Rust limit samples vec with underscore capacity total underscore samples doesn't actually put 24,000 elements in the vector. It allocates enough memory for approximately 24,000 f32 as ahead of time. Initially, len 0 capacity 24,000 then every Rust samples. Push sample increases the length. The agent presumably did that to avoid the vector repeatedly reallocating as it grows. What the max 0.0 means this Rust let rec self controls the frequency of max 0.0 is basically for ordinary finite numbers Rust let rec self controls the frequency 0.0 L self controls the frequency so controls the frequency rec 440.040.0.0.0.0.0.0.0.0.0.0 max literally means give me whichever number is larger so Rust 440.0 underscore f32 max 0.0 gives 440 whereas Rust 440.0 underscore f32 max 0.0 gives 0 is just a lower bound clamp. The volume line uses the more general version Rust let volume self controls the volume clamp 0.0 1.0 which means 0 right where 0 0 1 right where 0 unchanged 1 right where 0 1 why did the agent put it there? Probably defensive programming. A negative frequency doesn't really make sense as an independent pitch in this application. Mathematically, so a negative frequency mostly gives you an inverted sign rather than some new negative pitch concept. The US frequency slider already prevents this because its minimum is 40 Hz, but the Rust engine doesn't know that some friendly React slider was a color. Something could eventually call Rust frequency minus 500.0 through WASM, so the agent may render tolerant of that. I would eventually move this validation. I don't love sanitizing parameters inside the inner rendering. Loop setup. I'd prefer untrusted browser input downward arrow set underscore controls downward arrow validate normalize downward arrow valid control state downward arrow render then render can trust this invariant. Frequency 0 0. Volume 1 duration 0 right now render protects frequency and volume, but interestingly not duration. That's actually more concerning because duration determines an allocation. Rust vec with underscore capacity. Total underscore samples eventually I validate controls when they're accepted, rather than partly validating them during rendering. About your React context change, your intuition was correct about why you need to use a state. The problem is that a use ref mutation does not cause React to render again. You have TypeScript const engine use ref t2 wave engine null null and later TypeScript engine the current new t2 wave engine React essentially says okay you mutated some private mutable storage. I don't need to render. That's the purpose of the ref. So you added TypeScript const is ready settings ready use a state false and TypeScript set is ready true now React renders again happens to read TypeScript engine current again and therefore sees the engine. So your reasoning is correct, but I would not implement it that way. The engine itself should be state TypeScript const engine set engine use a state t2 wave engine null. Null because the semantic event React cares about is engine was null downward arrow engine now exists downward arrow render consumers that's literally state. A ref is better for something changed.
The reason why I didn't.
A ref is better for something changed.
The reason why I didn't do this is because I did. I remember some other thing that I was implementing sometime that I did exactly like this and it was basically the same problem. And then they use state and ended up having other issues. So I think that I'm not gonna trust GPT here. I'm just gonna leave it like that probably with the use ref.
State. A ref is better for something changed, but React should not render. There's also a bug in your current effect. This is particularly important. TypeScript use effect. If is ready set is ready true. Is ready or changing is ready inside an effect that depends on is ready. Sequence. Render is ready false.
Yeah, the main downside of the way that I did there is that you can have, which is a very common problem on React, and that's why I think that's why people say you shouldn't do you shouldn't call data inside of React. You shouldn't call APIs inside of the use effect, because use effect can easily create an endless loop where whatever you put here is like if this value changes, basically it runs the effect again, which makes the component render again. So this sometimes can create like a thing where you're changing the component, then it renders again, then it makes the component change again, and then it becomes like the infinite loop. So that's the biggest risk here. So it feels kind of fragile because like if you, for whatever reason, like forget the flag, then it probably loops forever. But I think for this thing that I'm building, like because it's not really something I care about that much, I think it's fine to leave it like this. But maybe there is a better way to use the use graph here somehow, or to initialize in another way. Yeah, whatever.
Sequence. Render is ready. False engine. Null downward arrow effect executes downward arrow engine. Current engine settings ready. True downward arrow. React renders downward arrow because it's ready changed. Bold effect cleanup executes downward arrow engine. Current null downward arrow effect executes again, so you've turned engine initialization into an effect cycle. React strict mode in development can make lifecycle bugs like this even more confusing because effects are deliberately exercised more aggressively. Also, TypeScript engine.current doesn't make the engine non-null at runtime. Only tells TypeScript, trust me. On the first render, engine.current is still actually null. I would go back to engine as state. Interestingly, your originally uploaded provider already had the better lifecycle. TypeScript const engine. Set engine uses state key2wave engine null and then set the actual engine after asynchronous creation. Removing WASM adapter doesn't change that. I think removing WASM adapter can be perfectly reasonable. It was extremely thin, but I would preserve its responsibility even if you remove the class. In other words, I would not make the React context know this. TypeScript importing WASM from WASM package core instead. React context downward arrow key2wave engine create downward arrow in WASM downward arrow create WASM engine. Your key2wave engine becomes the WASM boundary itself. Conceptually, TypeScript class key2wave engine static case and create. Promise key2wave engine await to initialize WASM return key2wave engine WASM engine then the provider remains boring. TypeScript const engine. Set engine uses state key2wave engine null use effect let dispose false instance. Key2wave engine null avoid key2wave engine. Create but then created if dispose created the free return instance created set engine created return dispose true instance. Free then TypeScript key2wave context the provider value engine ready engine null no is ready. No use ref. No non-null assertion. No effect dependency cycle. And initialization remains outside the UI layer. The old WASM adapter existed specifically to isolate generated bindings from the rest of the front end. I agree that the whole class may be unnecessary, but I moved the boundary into key2wave engine, not into the context. Now the interesting part, resetting accumulation. I think you should distinguish release currently.
Actually, it might be a better idea to just use if I have credits, free credits on client, just use the agent to do this small refactor here, because I agree that this is probably better. So it's telling me to create a static function again on the engine, then initialize both. It's basically the same thing, and just call the function the same way that it was being done there before. It's kind of annoying to do it.
Release currently held keys from reset the current composition sequence. Those are different operations. Right now you already have rust event underscore history vec keyboard event record press underscore keys vec string in rust. So I'd introduce something conceptually like rust pub res underscore sequence must self event underscore history clear self. Press underscore keys clear. I would not reset controls there. That means waveform triangle volume 0.7 duration 0.5 sequence. ISDFASD reset waveform triangle volume 0.7 duration 0.5 sequence. That's
telling me to use clear as well.
That's intuitive. If you want everything back to factory state later, rust reset underscore all could additionally restore controls. Later, rust reset underscore all could.
Instead of making it equal to the thing here, makes more sense to call clear. I'm not really sure if making it, I think probably when you assign to equal again, it's gonna delete the memory when it goes out of scope, but I think that this is obviously better.
Could additionally restore control state default. More importantly, make waveform derived state. This is an architectural invariant tied up now. The accumulated waveform should not itself be the authoritative state. The sequence should be authoritative, and the waveform should be derived from it. So don't think. Keypress downward arrow mutate waveform downward arrow mutate waveform downward arrow mutate waveform downward arrow reset waveform think. History A S. D downward arrow render downward arrow waveform then. History A S. D. F downward arrow render downward arrow new waveform reset. History downward arrow render downward arrow empty silent waveform that becomes enormously valuable later for ML because you get a deterministic interface. Sequence rightward arrow waveform rather than some hidden series of imperative mutations. Your automaton idea, this is where I think you're heading towards something genuinely useful. I would just change the wording from finite automaton produces audio to finite state transducer interprets symbols into synthesis instructions. A normal DFA is generally thought of as current state, symbol downward arrow next state for key2wave you want. Current state, symbol downward arrow next state, audio output that's much closer to a Mealy machine / finite state transducer. For example, state starting downward arrow state low output, base frequency 220 state low S downward arrow state right output, add harmonic 2 state right D downward arrow state. Modulated output, modulation rate 4 Hz now. A rightward arrow S rightward arrow D has meaning as a sequence, and D rightward arrow S rightward arrow can produce something completely different. That's exactly what you want before ML. I would separate the finite state from continuous audio state. This distinction is subtle but useful. If your state contains rust frequency F32, volume F32, modulation underscore rate F32, then technically you don't really have a finite set of states anymore. So make two concepts: automaton state finite discrete synth state continuous audio parameters, then symbol downward arrow automaton state rightward arrow. Automaton state downward arrow command downward arrow synth state something conceptually like rust enum automaton state start rising, falling, dense, sparse, and rust struct synth state frequency F32, amplitude F32, harmonic underscore mix F32, modulation underscore rate F32, then transition emits something like rust enum synth command. Set frequency F32, multiply frequency F32, add harmonic.
It's basically talking about the exact same thing that I was talking about before. Is this relationship between the controls, which are like static and fixed throughout the whole thing, and the commands, which are history based and change the baseline. So the way that I'm seeing is that the controls are like the baseline of the wave, and then the key strokes are gonna be what changes the baseline to form the final waveform. And I also need the history as well. I need to like save the history somehow, instead of just capturing the current state.
Harmonic, U32, gain, F32, set modulation F32. You don't need to implement all of those yet. It's the separation that's important. Then render changes roll today. Render downward arrow read frequency downward arrow generate sine wave evolved toward. Render downward arrow parse keyboard history downward arrow run automaton downward arrow derive synth state audio program downward arrow synthesize samples downward arrow. VEC F32 conceptually. Rust buffer underself. VEC F32 lit program audio automaton interpret self event underscore history synthesizer render program self. Controls sample underscore rate. I particularly like recomputing the automaton from the history from the beginning initially. Don't optimize yet. If history is A S D do start downward arrow state 1 downward arrow S state 2 downward arrow D state 3 every time you render. Why? Because then history controls completely determines. Waveform no hidden cached automaton state can get out of sync. Later, if you have thousands/millions of events and it matters, you can cache incremental state. What should the symbols actually do? I wouldn't initially do a 220 Hz S 240 Hz D 260 Hz because that doesn't really exercise an automaton. I make transitions important. For example, imagine you keep the previous physical keyboard position. Moving right, a rightward arrow S rightward arrow D rightward arrow F could increase pitch. Two semitones each transition moving left. F rightward arrow D rightward arrow S rightward arrow A could decrease it. Moving between keyboard rows, a rightward arrow W S rightward arrow E D rightward arrow R might modify harmonic structure. Repeating, a rightward arrow might increase modulation or add another harmonic. Now the keyboard becomes almost spatial. Keyboard motion downward arrow symbol transitions downward arrow audio transformation. That's much more interesting than static key to frequency mapping. Collections of symbols become grammar, then you can introduce recognizable sequences. For example, ISD could be a pattern recognized by your machine. Start downward arrow SO downward arrow SIS downward arrow D pattern ASD entering pattern ASD. Could produce switch waveform at harmonic change envelope ET setter and now you're creating a tiny audio language. That's also a fantastic conceptual bridge toward ML. Today keyboard sequence downward arrow finite state. Interpreter downward arrow synth program downward arrow DSP later. Keyboard sequence downward arrow neural sequence model downward arrow synth program downward arrow same DSP. Your model doesn't initially need to generate 48,000 floating point samples. It learns sequence rightward arrow synthesis decisions, which is much easier to reason about. Your two modes then fall out naturally. I think these are really different views of the same sequence engine. Immediate mode downward arrow history downward arrow interpret downward arrow render 0.5 SEC downward arrow display play S downward arrow history S downward arrow interpret downward arrow render 0.5 SEC downward arrow display play each keystroke lets you view the current state of the machine. Composition mode here I would eventually introduce an audio timeline. A downward arrow audio event 1 S downward arrow audio event 2 D downward arrow audio event 3 canvas 0s 2s. You see it evolve, but don't necessarily play anything yet. Then play downward arrow render complete timeline downward arrow web audio that's extremely compatible with your monkey type idea because typing timing could eventually become timeline timing. The next implementation sequence I use fixed the React engine lifecycle first. Put the engine in state. Remove is ready. Keep WASM initialization inside key2 wave engine. Add reset underscore sequence to Rust. Clear active event history and press key state without resetting controls. Create a normalized symbol representation. Don't make your automaton consume raw browser strings forever. Have something like input symbol /sound symbol derived from keyboard event record. Build a tiny mealy style audio automaton. Start with perhaps 3 to 5 states and make transitions change 2 or 3 synthesis properties. Make render replay history through the automaton. For now, recompute from scratch each time. This gives you the crucial invariant history rightward arrow synth state rightward arrow waveform. Then add accumulation/timeline rendering. Once the interpreter exists, you can decide whether its output means current synth state or a sequence of timed audio instructions. The most important design choice is this. Keyboard event record downward arrow normalized symbols downward arrow finite state transducer downward arrow synth program synth state downward arrow sample generator downward arrow VEC F32. I think that's substantially more interesting than merely making render inspect the last key, and it gives you a clean future ML substitution point without throwing away the Rust DSP work you're doing now.
And so now the thing that I'm thinking about, which is something that I've been struggling with, like deciding, that my first instinct is to just have GPT give me a prompt so that I can send an agent, and the agent changes everything, because it seems kind of redundant to just type this stuff, then go through the friction of figuring out the errors in Rust. But then my concern is that like I'm gonna lose muscle memory and also not learn the APIs, because you learn by friction, obviously. So I'm not really sure if I should just try to write it down the final automata, or if it's just because the issue is that like there's this mismatch between like I can already see the whole system and how everything should be, but then if I type myself, then there's a lot more friction, which is kind of annoying because then it makes me deviate from the thing that this stuff, like the core idea of the thing, which I actually care about. So I'm not really sure what. Okay, I think for this it's probably better to just prompt the agent and to have it do the automata, like the structure, the skeleton of the other thing, and then I spend some time discussing with GPT like what would be the most interesting way to set this up here. The other thing that is annoying that has like to do like this plumbing of I need to connect the reset history with the front end, and then I need a way to also change the style of the front end to have, like GPT was saying there, where I can have multiple different timelines, just like on normal audio software. Shows monitors. Then, fuck. Like just like normal audio software where I have multiple different timelines, and then you can build the final waveform by connecting, like by merging all of them. So like in one track you do something, and the other track you do something else. This is another stuff that I think I could do it here on the one, but I'm not really sure how useful that would be. But the main one that I'm thinking about is to accumulate or to save the state. I think the way it's working now is that it's just capturing the current state of the parameters. And if I add the keyboard, if I change the render function to add the keyboard's history here, then when I press, it's just gonna change every time. But I think depending on the way that I do it, it will capture the whole state, but it won't allow me to. I think I need to do like two tracks: one that I save the one that I build the wave, and the other one that I save, so I can reset and like do more stuff. Let me see. I think that this is the thing. It's kind of different than the way that I'm thinking about. Because depending, like if I add the event history here, if I make the render consider the event history, then yeah, but it's just gonna it only plays when I click when I press the key on the keyboard. So I don't think that's gonna. It accumulates the effects. That's the thing. If I put the events, then it's gonna accumulate the effects. But I need a way to just press one key and then see what happens on the. So it's kind of different. I'll be right back.
Yes, I think the two-wave idea fixes an important ambiguity in the current design. What does this key mean by itself? And what has the sequence built? Are two different questions and should have two different rendered buffers. The current core engine only has one control state, one event underscore history, and one render producing one buffer, so it currently has no way to represent that distinction. I would do the core part yourself by personally implement these parts yourself. The normalized keyboard symbol type the automaton state slash transitions. What each transition means acoustically the history rendering. Semantic standalone KVS sequence behavior. Those are the actual research slash learning part of key 2-wave. An agent would be useful afterward for mechanical work such as adding the second waveform component wiring mode. Toggle exposing another WASM function, updating TypeScript snapshot types, writing repetitive tests. Once you define the invariants, I wouldn't delegate the automaton design yet because that's exactly where you're discovering the conceptual model. File name create sequence underscore automaton dars. I prefer that over automaton dars because it tells you what the automaton interprets. Eventually, I can imagine engine dars sequence underscore automaton dars synth dars where the responsibilities become engine dars zones application state history sequence underscore automaton. Our symbols transition sequence interpretation synth dars converts audio parameters instructions into samples. You don't need synth dars yet. We can extract that after the first automaton works. The two waveform model I would call them preview wave composition wave or internally preview composition preview press A downward arrow interpret A in isolation downward arrow generate samples downward arrow preview waveform downward arrow play then S downward arrow interpret S in isolation downward arrow generate samples downward arrow preview waveform replaces a downward arrow play S no history involved. Composition at the same time. A downward arrow S downward arrow A S D downward arrow A S D and A S D downward arrow sequence automaton downward arrow complete composition downward arrow composition waveform that buffer stays around until reset. I would not make the flag determine what gets rendered. This is one place where I'd modify your idea slightly. If you want to see both waveforms, render both. Use the mode to determine what gets played automatically. Something like Rusty playback mode preview compose then preview mode key down update preview waveform update composition. Waveform play preview waveform compose mode key down update preview waveform update composition waveform don't automatically play composition then you hit play composition when you're ready. That solves the overlap issue while preserving both views. If your flag instead changes what render means, you'll start getting awkward state. Render means one thing in mode A, render means another thing in mode B. I'd rather explicitly named operations. So I would stop having just render your current Rust buffer on yourself. Vec F32 is fine for the proof of concept, but the application now has multiple meanings of render. I'd head toward Rust render underscore preview, render underscore history, not necessarily those exact signatures yet. Conceptually, render underscore preview symbol downward arrow standalone sound for symbol end. Render underscore history downward arrow sound produced by complete sequence is much clearer than Rust render mode because the type /API tells us which operation we're performing. Now here's what I think is the really interesting. First, automaton don't start by making the entire history magically produce one mysterious sine wave. Instead, make the automaton emit an audio description after every symbol. For example, initial state downward arrow state output, frequency 220 amplitude 0.5 s downward arrow state is output. Frequency 330 amplitude 0.6 downward arrow state ASD output. Frequency 440 harmonic 2 now your sequence. ISD produces tone 1, tone 2, tone 3, 220 Hz, 330 Hz, 440 Hz. Harmonic in your final composition is this gives you the accumulation behavior immediately. Important distinction. Standalone AVS contextually this gets especially interesting. Suppose standalone, a downward arrow start rightward arrow downward arrow 220 Hz, so the preview wave shows 220 Hz. But history, S rightward arrow D rightward arrow might mean state D downward arrow 180 Hz modulation, so the same key can have two different interpretations. Preview, a starting from initial state history, a starting from whatever state previous. Symbols produce that's exactly the kind of context dependency you're ultimately interested in for ML. It gives you a fantastic invariant. Preview answers what does this symbol do from the initial state, while composition answers what does this symbol do in this context. I define an intermediate audio object. I would not let the automaton itself push F32 samples. That's mixing two different mathematical objects. The automaton operates over symbols and should produce something like audio parameters conceptually. Maybe Rust struct tone spec frequency F32 amplitude F32 duration F32 eventually Rust struct tone spec waveform type frequency F32 amplitude F32 duration F32 harmonic underscore next modulation. Then your architecture becomes keyboard symbol downward arrow sequence automaton downward arrow tone spec downward arrow sample generator downward arrow vec F32. This separation is extremely useful. Then history rendering becomes simple. Imagine history ISDF you create a fresh automaton state initial process a downward arrow state X tone spec S downward arrow state Y tone spec SD downward arrow state Z tone spec DF downward arrow state Q tone spec F. Then synthesize each tone spec A rightward arrow vec F32 tone spec S rightward arrow vec F32 tone spec D rightward arrow vec F32 tone spec F rightward arrow vec F32 and concatenate history samples A samples S samples D samples F samples. That is probably the first history based render experiment I would build. It's easy to understand, easy to test, easy to visualize, and sequence ordering matters. Your reset now becomes trivial because the samples aren't authoritative. History is authoritative. Current Rust already stores Rust event underscore history vec keyboard event record is the accumulated source data. So reset downward arrow history clear downward arrow render underscore history downward arrow empty composition preview doesn't have to reset at all. You can still see the most recently pressed standalone key preview a composition empty. That feels right. Controls history yes, but don't make control underscore history vec control state yet. This is where your second idea becomes more interesting. You've noticed that there are really two kinds of events happening. Keyboard event and control change. Currently the engine separates them. Event underscore history controls and controls only represents the latest value. So consider the sequence frequency 220 S frequency 440 DF if you only keep current controls. Then later rendering the history sees ISDF controls. Frequency 440 you lost the fact that NS happened while the baseline was 220 Hz. That's a real information loss. I think the eventual answer is one unified timeline instead of Rust event underscore history vec keyboard event record control underscore history vec control state. I think the more interesting architecture eventually becomes something conceptually like Rust enum sequence event input control then timeline control frequency 220 S control frequency 440 D control volume 0.4 F. Now the renderer can replay reality start. Controls downward arrow frequency 220 downward arrow S downward arrow frequency 440 downward arrow D downward arrow volume 0.4 downward arrow F. This starts looking much more like composition. And this naturally leads to track 0 analogy is exactly where this can eventually go. Imagine composition track 1 base frequency 110 events ISDF track 2 melody base frequency 440 events QWER track 3 texture triangle modulation events ZXC. Each track could eventually have track based controls event timeline automaton interpreter. Gain new rendered samples then track 1 samples track 2 samples track 3 samples downward arrow master waveform and now you arrive naturally at mixing. But I would not implement track yet. There's a very useful progression here. Current control state keyboard history next single sequence downward arrow automaton downward arrow composition then keyboard control events downward arrow single timeline downward arrow composition then track timeline controls then vec track downward arrow mix downward arrow master waveform. I would resist jumping straight to the last one because you learn what track actually means by building the single timeline. First, it also gives ML a much richer input later eventually instead of only ISDF. The model could see control frequency 110 delta t 94 milliseconds S delta t 71 milliseconds control volume 70 and potentially multiple tracks track identity symbols timing synthesis state control changes. That's a significantly richer sequence modeling problem. So what I would physically do next create sequence underscore automaton dollars then do not touch render immediately. First answer 3 questions in that file. 1. What is a symbol? 2. What finite states exist? 3. Given current underscore state symbol what is next underscore state tone spec start ridiculously small. Maybe states initial low high and only 3 symbols. ISD get this working. Initial A rightward arrow low tone spec low S rightward arrow high tone spec high D rightward arrow low tone spec. Then we modify render because once the automaton can answer symbol rightward arrow tone spec the rendering change becomes almost mechanical. History downward arrow filter key down symbols downward arrow feed symbols through sequence automaton downward arrow collect tone specs downward arrow generate samples for each downward arrow concatenate downward arrow vec F32. That's the point where I start editing render. And I preserve the current sign equation initially. Don't simultaneously invent 4 waveform generators, envelopes, mixing, tracks, automata, and control timelines. Let the automaton's first output simply determine things like frequency, volume, and duration, while your existing sign generator remains the known good final stage. That will give you the first genuinely sequence-dependent Key2 wave without making the experiment impossible to reason about.
Okay, so I'm going to stop streaming now, and I'm going to I'm going to use an agent to refactor the context again, so that it uses a function and reverts back to the way GPT was saying there, use the state directly, because this might be better. And I'm thinking that like this could grow actually to something much more complex. Now that I'm thinking about it with GPT there, because like what I can usually do is just create multiple different tracks, like it says there, then create mixing, and then create machine learning on the background as well to learn from the history of each track. That would be very interesting. But I want to do like the foundation faster. I don't want to do this stuff because kind of redundant, and I already have an idea of how. Like the only thing that I'm not going to use an agent is going to be the class, the automata class. I think that one is worth it to spend time like just thinking about on my own and then trying to do it on my own. But I'm gonna have an agent to do everything else, like the whole structure, the skeleton. Then I'm gonna probably discuss this with GPT as well to like the core automata as I build manually. Then probably next time, once I have like all of this set up, then the next step, interesting step, is gonna be to figure out how to. There's 2 different paths that I'm thinking about. One is to build the machine learning in Rust directly, and I'm not really sure, but maybe I can do both. The other path would be to use PyO3, which, from what I've seen, is something that allows you to write, to use Rust code from Python. So I could create this PyO3 crate next to the one that I already have, which is basically a bridge to Python. Then I create another Python project there, and then I do the training using Python, like PyTorch and stuff like that, and do like the setup on Rust. And I think I might do both actually, because I want to learn how this spiral tree works. And then I'm gonna have to think about like what interesting ways I can train models to learn from the history, or to the other thing is obviously to run experiments as well. That will be interesting. I'm just gonna stop streaming here. Probably next time I'm just gonna continue to build this. So see you then.